Yeah, good morning, good afternoon, and good evening, depending on where you are joining from. I am Godric, the lead facilitator for Online Safety SIG. And when we say online safety, we are more of advocating for a safer internet, and we educate and equip people and organizations on how to use the internet in its fullest potential in a safer way. Today, we came about with this webinar that will educate us on the recent global outage that it highlighted the need for resilience in our software systems and internet connectivity.
My name is Olaf Kolkman. I'm a principal at the Internet Society. In essence, I am a technologist, senior spokesperson. I dabble a little bit in policy issues and in advocacy. I have a background in internet technology, specifically in the architectural pieces that keep the internet together. I have a bit of a history in computer security and thinking about computer security. And these type of issues, like occurred exactly a week ago, are things that always fascinate me and trigger my interest. A number of you might have seen our post about the outage. That was written on the day of the outage itself. For us, it was a means to quickly take a perspective on what is the impact on the internet and what's the relation to the internet with respect to this outage. Is this an internet-related thing? The answer is mainly no, although there are a few yes aspects to that question as well. We'll probably talk about that. But for us, that was sort of the reason to write a blog, to look at this evolving outage and think a little bit about and assess a little bit what that means with respect to the internet. We are the Internet Society, so that's sort of a logical look. As I said, this was not a real internet outage, although there are aspects of the internet, namely the interconnectedness of all of us, that are the reasons why these tools went down, and we'll get into the details a little bit later, why those tools are implemented in the first place. They have to do with being globally connected, with seeing threats all across the world. And also the speed by which this event took place has to do with the global nature of the internet and the fact that the company somewhere in the US can start pushing updates across the world, starting in Australia, where we saw the first services go down.
Hello, welcome. Thank you all for joining in this session, and thank you, Godsley, to the Online Safety SIG for hosting the session. I would also just put in a plug too that the Online Safety Special Interest Group here of the Internet Society is open to anyone. So any of you, if you are not a member, you can certainly join in and be part of that special interest group. I've been working with the Internet Society for about 13 years, working with the internet since the 1980s in various different ways, and been focused a lot on online security in my different roles and communications, lots of different aspects around that. In this particular case, one of the roles I've been working on the last year or so has been writing a lot of shutdown incident reports and things for our Pulse platform, which, if you're not familiar, it's pulse.internetsociety.org. And we do a lot there to track primarily internet shutdowns. We're looking at where the internet is being shut down by governments in particular and what they're doing and why. And we track that there, and we do a lot. But if you explore other parts of the site, we're also looking at resilience, which is a key word here of how do you ensure that the internet is resilient in your country, place, wherever else, those kind of things that are going on. So that's a lot of what we do on the site. We have other pieces there. If you're interested, you can go on Pulse and look at the country reports, which will show the resilience, the adoption of technologies, and other pieces for your particular country. So when this was coming about, when this outage started happening, as Olaf said, we were concerned because we started to see people and you still see it, the headlines are, the internet is down, global outage, everything else. And it was for a lot of the things. But part of our message in that post, et cetera, was the internet's still working fine. The connections are still going, the things are happening. The software and services running on top of those for many people are not running. And in some cases, that was a significant aspect. But part of the strength of what we saw was that a lot of other things did not fail. If you weren't using Microsoft Windows and CrowdStrike as your endpoint detection and response software, if you weren't using that, then your systems were still running. If you were using Linux, if you were using Mac, if you're using other systems, Windows with other products like that, it still worked. So that was part of what we looked at there in that post and other pieces around that. Now, when you look at what actually happened, to dive in a little deeply into that, CrowdStrike is an example of what are typically called endpoint detection and response systems. They are software that is installed to go, and you could think about it as sort of an evolution of the antivirus software that many of us might have run at some point in time. They detect more than just viruses that you might get in email or something. They detect malware, different kinds of security attacks, different kinds of things that happen on your system, on a server. The reality is there's a lot of people who attack on the internet who are seeking to do it in some different way. And so many organizations use these type of software from a number of different vendors to go and protect their servers and systems. The challenge that we get into here is that with operating systems, there's generally two ways that an application or program runs. It's either in so-called user mode, which is what almost all of our applications run in, or they run in kernel mode, which is the very basic core center of the operating system. Now, what happened here is that CrowdStrike chose to implement their system using a device driver, if you think about it, like you might have for a printer or something else. They wrote their code to go and work at that level because they want to have the vantage point where they could see everything happening on the system. To provide the most protection, they wanted to be right there at that. So this particular software, this driver, had to run down in the very core of the operating system, but had to go and do that. So that was why this was going. Now, that driver, that software, went through Microsoft certification, went through all sorts of stuff. It's there, it's installed, it works, it's there. But they also, to ensure that it always was agile, was kept updated, they devised a mechanism where that software could get updates so that the updates could provide you with the latest protection. Thinking back toward antivirus software would often have new virus definitions. And so you would get that to know about the latest and greatest things. This is similar, but more for kind of applications, malware, et cetera. Well, one of those, they would pass along these updates to make the system search for more. And they did it in the past. They had some that came out in March. They had some that came out in April, and these were pushed out to all of their things, and it worked. This time, it didn't work. And the update that came out with the new applications, new things to look for, came out, was sent out to these systems. And then because this software runs in so-called kernel mode in this thing, it goes to the very core of the operating system. When it rebooted, it just didn't work. It panicked, it died, and which is why you saw these blue screen of deaths all around the world. So this is a core piece of why that happened. Now, the other part of that is to fix that, IT people had to go around to every single device and go in there and restart it and make some changes to remove this update or to use a new update, et cetera. So you physically had to go to each individual device and go and make it, which is part of what made this. It wasn't something that could be solved remotely. You had to actually go there and make this change. Some virtual machines you could do remotely, et cetera, but there were some, it involved a lot of hands-on going and changing. So that's what happened and why this was such a major piece. We'll talk a little bit later about some of the things that might have been done a little differently, but that's the core of that.
I have a question for all the people on the call. Raise your hand if you were impacted by this bug, or even better, if you were responsible for a system that had this bug. Is there anybody who had life experience? Because I didn't. Chris is raising his hand. Chris, do you want to talk about that?
Well, I can talk in kind of general terms in terms of how it impacted where I work and the recovery from that. So I was actually online doing some work when this happened. Microsoft's initial response was, hey, all your virtual machines don't have any disks anymore. And of course, that's a very odd message to get from Microsoft, but indeed that was effectively what had happened. And so a lot of our infrastructure that we put in the cloud because you want it to run no matter what was no longer running. That included a firewall product where the master firewall, of course, lives in the cloud. So many of our firewalls went into kind of an automated mode, as well as some of our monitoring systems are in the cloud. And so we did not get the email that some of the things went down because, of course, the system that tells us it's down was in the cloud. We luckily weren't too paralyzed, but it did affect us until Microsoft brought those virtual machines back for us. But beyond that, in terms of having to recover through BitLocker and stuff like that, luckily we did not have to do any of that in our systems.
Cool. Thank you for sharing that.
Thank you.
Rondelo Bluza, I actually don't know how to pronounce your name. I'm sorry for that.
It's actually Rondelo Bluza, but you can use Keith. Keith is fine. It's my second name.
Keith.
Yes, thank you. So I'm down in South Africa. I'm in Port Elizabeth, Gqeberha. And in general, so a lot of banks went offline. So it was very hard to do transactions, like your everyday things. And a lot of people got stuck. And then I think maybe as a precautionary measure, some banks actually began to take some of their functionality offline. I'm also at Nelson Mandela University, so we use a lot of Microsoft core products, your Teams, your server, your everything. So a lot of stuff was slowed down, and even with regards to maybe research, it was very difficult to put work together. There's a whole lot of stuff that went offline. And so that was a big challenge. I do a lot of research, and then so that was a big challenge.
And did you have to go out to manually reset machines and delete the appropriate files?
I think it has improved over time. I'm not in the IT department per se, but although my background is in telecommunications and IT, so I'm in robotics. But then over time it has improved, but primarily most of the systems were in general like very compromised for a while. I think after some time, I think CrowdStrike then issued some kind of solutions to like especially people managing macro setups, then I think it gradually has gotten better, even though it's not back to 100%. As far as I know, maybe it's still slow.
Yeah, then recently the CrowdStrike team published something on their website, basically explaining what happened. Can you summarize that a little bit?
Yeah, and you can see, actually, it's kind of a little strange. It goes to their hub where they then have different information, and you can see there's a statement that says preliminary post-incident review. And then a little bit farther, there's a technical details part in there, which has some additional information. This was actually something that we were very pleased to see. If you look in our blog post, one of the things we had mentioned was that we hoped that CrowdStrike would do this, because having this kind of incident review, this post-incident area, some people call them post-mortems, whatever, having this after incident thing helps us all learn. Because the reality is we will have these outages. We've had them. We will have more. We just recently published a post on the Pulse blog about the Rogers incident in Canada that happened 2 years ago. So we will have these. The importance is that we learn from them and that we see what goes on. So if you look through that document and look at the pieces that explain, more or less, they get into more details about what I said as far as how it actually works, the particular file, they call it a channel file, the kind of things that happened. They also explained a bit about what happened. Their bug checking, their automated testing system that would go and check these kind of things, seems to have had a bug. It failed, and they didn't notice it. They didn't find any issues in previous updates. So whatever the bug was in their testing system, it went unnoticed. And so when they went to go through this, it looked like it was fine. And then it was pushed out. One of the big challenges they identify is that they pushed it out to all 9 million endpoints or systems at the same time. So it just was, poof, there it goes globally to the world. And everything failed then, started to fail around that. what they noticed and what they said to prevent it and to talk about that is what they did was that global push, for instance, was something that other people don't do. For instance, Microsoft, who has been putting out system updates for many years now globally, they tend to go and push them out in a staggered way, in stages. They tend to send them out to a certain smaller set of sites first, which they do heavy monitoring on. And then once it gets out to those systems and they see no update, then they push it a little bit more, a little bit more, a little bit more, and a little bit more. And this kind of comes back to that question that we were talking about sort of later in here around what do we do in the future? How do we make sure this doesn't work? Adopting practices like that ensure that when you push out that update, it doesn't immediately take down systems all around the world. You're able to see and be able to monitor, check, and do that. And that's one of the things that they pledged that CrowdStrike would do in the future to certainly make sure it won't happen for their customers. Of course, we also would hope that other people will learn from this, anybody else who's doing these large-scale system updates, and they will similarly adopt the same kind of practice so that it doesn't go globally in one moment, push a button and there it goes. So that was kind of the big thing. There's a lot more that it talks about in there. They also pledged to have third parties engage in some of this testing and to do more testing themselves. There's a short PDF that you can look at if you just want to get the high points as well. Yeah. But I commend them, at least, on doing the level of detail they have done. And they've promised to provide even more detail in the future.
Yeah, sure. Thank you so much, Olaf and Dan. I think you've even covered 3 of our main topics for discussion today, but we'll possibly just move straight forward to other ones. So I wanted to ask Olaf, please, looking at these outages, I wanted to see if you can highlight some need for diverse operating systems and redundancy in tech infrastructure. And also maybe possibly if you can ask some examples of why redundancy could have mitigated this outages impact.
Well, I think that you hit the nail on the head there if it comes to some of the concentration and consolidation issues that we see on the internet. If you look at the internet ecosystem as a whole, there are a number of bottlenecks on things that we use in our technology stack. If it comes to processors, there is only a handful of processor suppliers in the world and a handful of processing architectures. If it comes to the operating systems that run on those processes and that allow you to interact with those processes, I would say you have less than 5. In essence, Windows, Linux, and macOS. And then there is a little bit of BSD, but macOS is actually a BSD system. So there is little diversity. If you look at what our cloud infrastructure in the world runs on, it's all Linux. If you look at your phone systems that you use, your mobile phones, it's either iOS, which is Apple, or it is Android, which is a Linux system again. So there is very little diversity on which we run infrastructure. I think that's problematic. That makes those pieces of infrastructure high valued targets. And even if you look at the tools that we use to build software, even there the diversity is very low. There are a couple of libraries that do encryption. OpenSSL is one. The name of another big one escapes me at the moment. It doesn't matter. There are building blocks implementations that we all use across the world to build our systems out of. And I think that's problematic. But I also think they're very hard to counter because there is so humongous amount of value in those products that everybody goes towards them and everybody uses them, and everybody, when they have improvements, will work on that kernel because that has the biggest impact, or that piece of software, or that operating system. So I think that the economics, basically the economics of scale, the economics of McAfee's law, a network becomes more valuable if more people use it, but also a thing that is developed in a networked way, like Linux, becomes more valuable if more people use it. I think that we are stuck with the situation that in the end we will have only 1, 2, 3, maybe 4 vendors of these critical pieces of infrastructure that we use in our digital economies. And I think that is the really essential issue of our times. Lack of diversity, in essence, in the building blocks of our society. There are a few places, though, where people have been conscious about this fact. I'm going to point to an infrastructure that I have been involved in my sort of technical history, and that's the DNS. I started my career at RIPE NCC, and RIPE NCC operates a root server. A root server is a machine that if you ask for a question like www.internetsociety.org, which computer belongs to that address, then conceptually, that question always first goes to a root server. If the root servers are not there, you cannot answer that question. So those are critical machines to the infrastructure. And when we were working with a root server at RIPE NCC, my boss, Daniel Karenberg, at the point said, I think that if you look at all the root servers in the world, all the root server operators in the world, they all use software that either came from Bind or is Bind itself. Bind is a software package. So open source, so the people took code out of that and built their own stuff. But in essence, it was all the same thing. And at that moment, he basically went off and started collaborating with an organization called NLnet Labs in the Netherlands. And I was involved in that project. We said, we're going to build a second implementation of name server software that we can run on these root servers. So we don't have a single piece, but we have a different piece. We're not going to claim it's bugless, but we can be fairly sure that it has different bugs from the original version because we did a complete new implementation. And that's actually what we started doing, and that became a product called NSD. And now, fortunately, other organizations have done this as well. Europe has done this, and the Czech registry has done this, and the product is called NOT, and there's another product of which I forgot the name. What's the Eurit project server, Dan? Help me out.
Sing it right now, too. But the point is, though, there's a diversity of choices.
Right. There's a diversity of choices. And within that set of root server operators, there are about 12 of them. They are very conscious to try and do nothing the same. They basically look at each other and they make their own choices. If you're going to run that operating system, well, I might not. If you are going to do your maintenance on Saturday, well, I might do it on Monday. If you are going to do, so they're trying to spread their culture and their technical abilities in such a way that there is no single point of failure, so to speak. And I would love to see that in a more conscious setting across other pieces of the internet infrastructure. On the other hand, I think that is going to be very hard. Take, for instance, cloud infrastructure. Many people use the same cloud infrastructure. Many people use Amazon, and there is very little different choice in cloud infrastructure if you have a certain set of requirements. It's very hard to end up somewhere else. Hey, Martin, you have a question.
Question is, could diversity also be that if you have an organization dependent on Microsoft products or one solution, that you put your update strategy such that you don't update all computers at one time?
Oh, absolutely.
Absolutely. Yeah. I would add on to what Olaf said. This is not a new issue, right? The Internet Society has been talking about this for a while. Back in 2019, we did a global internet report around consolidation in the internet economy. Now, 5 years later, some of that consolidation has only further heightened. As Olaf said, everybody pretty much runs things in the cloud. They do it on either Amazon or Microsoft Azure, to a lesser extent, Google's cloud platform. But there's a limited number of systems that are out there that people are using in these kind of environments. We have a section of our Pulse environment that looks at some of the market concentration pieces and parts in there. But this is the point. It is doing that. Just recently, there was a brilliant essay that I truly loved from Maria Farrell and Robin Bergeon about we need to rewild the internet. And they looked at things through the lens of ecology and forestry. If you think of a forest, and if the forest is only of one tree, of one type, then if there's a blight or an insect or something else like that, it might go and destroy all of the trees that are in that forest. a monoculture, if you think of it that way. On the other hand, if there's a diversity of trees, if there's a diversity of things, then that forest is resilient against the kinds of attacks, the kinds of things that happen, droughts, all those different aspects. And it's that sense that the internet began that way, certainly with a lot of different diverse systems and things. But then the natural thing is that as things grow bigger, you wind up growing and looking to go and grow at scale and be able to work at that. And so naturally, some of these systems evolve and we wind up concentrating more and more things in certain ways. That's just the kind of the natural evolution of most markets. But we do need to think, and this outage reminds us, how do we ensure greater resilience? How do we have that more rich, diverse forest? How do we have that kind of realm of things? So if you have a little bit of time, it's a great essay to read, to think about how do we ensure that we have resilience and those kind of things, not only in our cloud providers, but what happens here when things go offline. One of the challenges that we saw was some people were not able to go and update their systems because they couldn't actually get to the management systems to use them. Like earlier, our speaker who talked about his experience, they didn't get the email because the email was coming from the cloud or something on that line. Some people were finding themselves unable to go and manage the servers because there was another piece around that. We have to be looking at how do we ensure that we can continue to keep the internet functioning even when we have these systems on the internet. How do we keep those functioning when we have that? Part of it is this diversity and ensuring we have a number of different kinds of spaces around that. Now, just to be clear too, I should mention, I see a question here. This happened to be Microsoft Windows using CrowdStrike. There have been other outages, there have been other issues. I was listening to somebody who mentioned that CrowdStrike had an issue back in April with an update that went out on Linux, but it only affected a certain, even smaller percentage or something. So it's not that Windows happened to be the one, it was that it happened to have that kind of thing. There's this piece that we look at too, that this was so critical because it executed in this kernel mode, this very high permissions, this ability to go in the core of the operating system. We are seeing some things where operating systems are making it so fewer and fewer things can execute at that level. I was curious to learn as well that in Mac OS, for instance, CrowdStrike cannot run. Apple changed it so you can't have things that run at the kernel level. They have another layer above that, so you couldn't have this kind of panic. And there is some effort within Windows and within Linux to ensure that things can't run down at that level to cause this particular type. So it's an interesting space, lots of things going on coming out of this as well.
Thank you so much, Dan. I think you've given a brief highlight, but I would like you to maybe highlight again some risks and consideration in deploying such software at an internet scale. Maybe you can add more strategies that we can use to manage such scale updates.
Sure. So I guess I would ask a question. Who here, any of our listeners, I'll throw it out to people here, have any of you dealt with large-scale update systems? Or I'm curious what your strategies may be. If anyone wants to raise a hand, I'd love to get your perspective. In the meantime, I can talk a bit about what we're seeing. Like I said earlier, you have things like Microsoft with their system updates. You see it also with even Apple with their updates to apps that come out, Google with the apps in the Play Store, these different things. Anytime you have large-scale systems, you need to go and get those updates out in some way. Now, security updates are a particular piece, and oftentimes you want the ability to rapidly deploy updates. If there's something going on, you want to stop a global disaster by being able to get solutions out quickly to get them to systems, to protect them. So the impulse that CrowdStrike has here was, let's get those updates out fast to everybody to protect the endpoints. I work a lot with WordPress websites, and WordPress has an update system to get updates out. They also have a security update system where they can push an update out rapidly to everybody's endpoint and go and put that out there. So if there was ever something that was exploiting WordPress, Automatic, the company behind it, does have the ability to push that out and get it out to everybody to protect WordPress sites all around the world. Now, you have to go and enable that to make sure that you're willing to accept those things. Because as we saw here, randomly accepting automated updates can wind up causing a challenge. It can cause this kind of problem. But you're in control in that case. I think what was happening here was many people either didn't have that setting, and I don't know precisely what CrowdStrike allowed or not, or if they did, it was turned on, those kind of things that were there. What you saw in CrowdStrike's analysis was that they are intending to go and do a staged rollout. Actually, I see Chris has put a note in the chat where he said that we roll out updates over several weeks with monitoring the recently patched systems. And he has a test group, an early adopters group, ring 1, ring 2, ring 3, ring 4, all of that. And that's my experience with people working in system administration, network administration, is they have gone and doing that. And that's a great system, a great way to go and work with that. The challenge for security vendors is they're trying to figure out how do they push something out fast to make sure you prevent some kind of worm, malware, something that is affecting large systems all over the place. So they're trying to do it at scale as fast as possible to get it out and to get people protected and get their customers protected all over the world. So they're caught a bit. They've got a catch-22, whatever you want to call it. They've got this problem that they want to push out fast to protect everyone. But at the same time, they want to ensure it doesn't blow up like this one did. So they're in a bit of a bind. They have a challenge around that. I think what I've already seen, people in the enterprise network architecture environment are already saying is, we're going to do a little bit more of what Chris has suggested in the chat, which is we're going to go and stage that rollout. We're going to do our own testing because we don't want this to happen again. We're going to go and make sure it works and go and do that, which is great. The trade-off again is if you're engaging with a security vendor to do this kind of endpoint detection and response, you want to get that update out fast. So the trade-off is speed versus the safety of the rollout. Those are the kind of challenges you have when you get into that. Any comments from people here? I'm curious about anybody else who's done anything here in this.
I think you've already answered the one for Chris.
Raymond asked a question about what is the possibility of having other applications aside iOS, Windows, and Linux. That's a difficult question. Building an entire operating system is an enormous investment. And the problem with that investment is that you have to overcome or at least be on par with the possibilities that are offered in the market currently. If you take Linux, for example, as a system that was developed in the mid-90s, I would say. And it had a chance to co-develop with the rest of the OSs. And there are a few other OSs. There are a couple of BSD families out there, OpenBSD, FreeBSD, NetBSD, that all have their niche, but they're not used that much. Because also, if you want to build infrastructure on a specific operating system, you are investing in that specific operating system. What you invest in running on a Windows system, you probably cannot run immediately on a Linux system. And what you run on a Linux system, you might not be able to run on, say, a FreeBSD system. And so there is value in being interoperable with what is currently in the market. If you build something new in terms of an operating system, then it is on you to create something by which the current applications can run on your system. Otherwise, your operating system is not that valuable. So it's going to be very hard to introduce something new in the market. Okay. If you look at the browsers, which is another type of market, there is actually only 2 browser engines in the world. Or maybe 3. It's the Google Chrome engine and the Safari engine. Those are the 2. And perhaps Microsoft has its own engine. I'm not 100% sure if they use a Google engine.
Yeah, it's Chrome underneath
Mozilla.
Edge.
And there's Mozilla, yes. But again, not more than a handful. And there is little competition. Again, in order to bring a new browser in the market, you have to provide all that functionality that current browsers have. And the current functionality of browsers is deeply complicated. You have to be able to do video, WebRTC, so video calling and web streaming and all kinds of authentication mechanisms, and security stacks need to be well in order. You have to implement all kinds of complexities. People who are trying to do something alternative will have a long way to go. I recently read something about Ladybird at ladybird.org, and they are trying to do something new in the browser sphere, writing a new browser from bottom up. But I bet you that they have years to go before we can use that in a similar way as we use Mozilla or Chrome today. So the real underlying issue is that with creating that diversity in our digital ecosystem is about the economics of the case. When you bring in a new innovation in this space, you have to convince the rest of the world that your innovation is better than what is already out there. Otherwise, people will stick to what they have and won't move. Very problematic.
Thank you so much for that insight as well. As we are wrapping up, we would like to look at when we talk about enhancing resilience in the data. Let's look at this outage that has happened, either Olaf or Dan. Can you give me some key lessons that was learned through this outage, and maybe possibly some best practices that we can use to improve this software systems and network?
I think some of the key things that we see out of this is people need to understand the systems that are there. In some cases, this caught a lot of people by surprise because they didn't actually understand that this could happen. Sometimes people tend to sign up with a vendor or with a system because they want to solve a very real problem. We want to protect our servers against attacks. So you sign up with a service, but you may not necessarily understand the ramifications of that. What happens when you wind up doing that is that somebody's going to push updates to your services. And so I think understanding the systems that you are using is a key part of it. And that's not only for us as consumers, but also for vendors to help them make it more clear. I expect a lot of people are asking their vendors right now saying, could this happen to me? Could something like this? So that's kind of one piece around this. The other part is monitoring. Part of what was identified here was that there wasn't necessarily full monitoring by CrowdStrike on all of its updates, but also by other different entities on some of their systems. Ensuring that you're monitoring what's happening on your systems, what updates are coming in, doing that. Some of these systems, because of this large-scale deployment of updates, it's going to require IT teams to do what Chris has mentioned here in the chat as far as having a more deliberate system of going and installing updates, which has a trade-off. More time, more budget, more money to have staff to go and do that. But on the other hand, it will ensure that you're not necessarily taken, out by an outage of this kind of scale. The other thing I think we all collectively have to recognize is that these outages will happen. The internet by itself, the nature of everything running and our software that we're running, it is more and more complex. We are using systems that are cloud-based, using this library, this thing, this. We're creating very complex systems, which give us the benefits and the opportunities that we have to do all the things we do. But the complexity of those systems means that there are a lot of moving parts and a lot of things we have to understand in different ways. So I think those are the kind of ways. Obviously, if you're a vendor who's pushing out these things, you've learned a lot of lessons about needing to have enhanced testing, automated testing, staged rollouts, other pieces like that. But for consumers and individuals, I think for us, it's a lot of looking at what are our systems, what can we do around this, and going back to that resilience, looking at what are the single points of failure. How do you ensure that you don't have as few of those? You may not have a lot of choices, but where you do have choices, can you look at that? So those would be my couple of takeaways there.
Yeah, I want to add to that. The dependencies on our digital societies are not only technical dependencies. We all know that discussions about digital sovereignty are raging across the world. Our dependency on vendors, our dependencies on cloud providers, and so on and so forth. So it's a hot topic currently, partly driven by these type of technological disasters, but also sort of triggered by geopolitical developments. And so very important discussions to have to understand your dependencies. That's understanding those dependencies on all levels. You as an individual, your company, your society, your municipality, your country, your region, etc., etc. Important discussions that are far beyond the scope of this presentation. Another aspect that I think Dan didn't mention is really thinking about how can we prevent these things from happening technically. In this case, that blue screen of death was caused by the ability to have a kernel module, as Dan explained, something that is really in the heart of your computer, being able to operate there and have a fault. The technical operating system community and the people who write programs and make these systems are actually thinking about how to protect our world from that. This is how we get to memory-safe programming languages like Rust and Go, where people can write programs that do not cause failures that will cause kernels and computers to crash. Similarly, an operating system like macOS has safeguards for people running within that trusted piece of the computer. And I know that people are working on standard mechanisms to really look into what is happening in the kernel with respect to packets flowing through, files being opened and closed, and those type of things. And those are exactly the things that virus scanners pay attention to. And to have a programming language that you can program that in and run things in the kernel in a protected environment. So people are thinking about this. This is also work that is being done at Microsoft. It comes from the Linux world, so to speak. Relatively new, I would say about 7 to 8 years old. That work became popular. And so there is innovation in making our world safer from a technical perspective. I actually believe that those type of things, while deeply invisible to most people, make a humongous difference and are relatively underfunded. What I don't think will help in this context is something like the Computer Resiliency Act, which will make vendors liable if they don't follow best practices. In this case, it is very difficult to claim, while there are improvements possible, that CrowdStrike was highly negligible. I don't think they were. I think they made a mistake. But I am not 100% sure that a tool like the Computer Resiliency Act in Europe would prevent these type of things. So those were my closing thoughts.
Yeah. Thank you so much for such a great point. So we've been talking about the importance of the redundant systems. In this session, we'd like to hear from our audience as well. So let's also hear from you. Do you have any questions or maybe any comments you would like to make?
I see a comment from Mauro Rios about we are in an independent world. I think that's the important part. We can deliver applications and systems at ways we never could before because of things like cloud computing. We could never create the startups or just throw up a virtual machine ever in the past without, well, it would be more challenging. It's made it very easy and simple for people to go and create things because of cloud computing platforms, for instance. But along with that comes the trade-off that we become dependent on a system that's more there. Ideally, sure, if you could put everything running on a server that you have running in a rack somewhere under your control, then you're limited. But that's hard, challenging, may cost a lot, whereas cloud computing has unleashed all sorts of capabilities there. So we are in a world of complexity. Our challenge is to understand how complex is it? What are the trade-offs? How do we go and work that? But I see we have a question, so I'll go to Jesse.
So Jesse, can you go ahead?
Mine is not a question. It's more of an addition to all the great things that you guys have said. I was thinking about this problem, and there's this growing movement where people are moving towards the open source product, and then the mindset of moving away from this cloud providers and then trying to have their own servers in their own spaces. And I think the world collectively or the technology enablers are all thinking about ways where we can break off these constraints that we have placed on ourselves as we wanted to grow quickly. Now, I believe technology is there where individually we can all host our own servers in our own establishment. And I'm happy, even though the CrowdStrike thing was very bad, it has awakened us, all of us, to start thinking about a better way forward and then a way to improve all the infrastructures that we have. It's the response and then how people are thinking about the comments and then the resolveness that is coming out of this instance. It's been great. I believe that we'll individually put in measures that will prevent such a thing happening in the immediate future. I thank you all for such a meeting and all the things that you said, the learnings and all that stuff. Thank you all.
Great. Thank you so much. So there is a comment and a question from Johan.
Could I actually just respond to something Jesse said? Another interest of mine personally is resilience in the face of natural disasters, climate change, extreme weather, things that we're seeing, and the ability to prepare and do that. And that comes into this kind of thing of how do you build applications and systems that run locally? I see somebody from our ISOC New York chapter on here who has done some work in that, specifically around disaster preparedness. And I think those are some great examples. But one thing I've been intrigued about is there's a growing, small, but a movement of people looking at so-called local first applications, where the application does a lot of the work locally and then does synchronization back out to a cloud or other services or things like that. So it's looking at some of that. This is way off the outage, but to your response, Jesse, I think part of it's looking at how do we get the benefits of the cloud and also the benefits of what we have on our systems. How do we ensure these things work in different ways? How do we explore different models? So I'm excited to see where some of that goes, because I think it could wind up getting to a place where we do have more resilient infrastructure and people are able to work with that. So back to you, Godsway. I'm sorry, there was a message you were wanting to respond to.
Oh, I think that was a comment and a question from Johan. He made a comment that CrowdStrike admits outage not a hack or cybersecurity event like SolarWinds or Prince Nightmare, where scope of outage was based upon number of clients under a set of conditions. CrowdStrike was 9 million nodes in 74 minutes. Question would be, was one of the inside jobs supposed to be quality assurance? I don't know if he's asking if one of the inside jobs was supposed to be quality assurance or something.
Well, clearly, quality assurance sort of failed. If you look at the post-mortem, that's exactly what they say. Something fell through. We had a piece of code that we shipped that caused this thing to break. So yes, quality assurance failed. I go always on the principle that you don't attribute to malice what can be attributed to incompetence or by mistake. So I think this is a valid mistake and not a inside cyber attack type of job. If that is what you're getting at, Joe, I'm not sure, but it is clearly a failure of quality assurance in the end.
Sure. Thank you so much. Just if you do the old hand or the new hand.
I wanted to understand the issue about CrowdStrike, though they are attributing it to an update. But if you are doing an update, I mean, you are looking at the technologies that are around, wouldn't it be proper for them to have done a penetration test, probably a side test before doing it on a live system, where you know that your system has to do with a lot of interconnected, let's say, components or technologies that just a little failure from your side cause a lot of setback.
That came out in their post-mortem or post-incident response that they said was that they had a failure in their testing. Now, without knowing precisely their systems, it seems like, from what I understand, they have an automated test suite, which you would expect, and they've tested it. From what I read in something else, they had tested it and worked for some previous updates that went out in March and April, and it went out fine. There was no issue. They were not aware that the automated test suite had a bug where it missed this particular case. So they ran through a test, they were doing that, but it missed this. So they had a failure in that and they didn't catch it. So what's one issue? They missed a test case that was there. I've worked in software and this in the past, and it is challenging to figure out if you catch every possible test case that's out there. But then what they did was they just pushed that update it went through their test suite, looked like it was good, and they pushed it out to all their 9 million nodes. And that's what we were talking about earlier. A better approach, and one they suggested, is to first push that out to a small number, monitor that, make sure that it actually worked fine, then push it to a larger group until eventually you get to everybody. This is what we're told, and this came out that Microsoft does it that way. Other people do it. So they have a small set they do, and this was not done. CrowdStrike just pushed it to all their 9 million endpoints right there. But now they have committed in their after incident report that they will now start to do this as part of the process. They will do more testing inside, not just relying on the automated testing suite. And then they will also push it in a staggered process. So if there was an incident that happened like this, they would contain the damage to a smaller number of systems before it hit everywhere.
Can I add something to what you just said? For the automated test procedures for our organization, we recently did a review. We provide software for institutions, and we recently did a review on how we do our CI/CD. And then one thing I realized is that most of our automated tests is done on Linux machines. During testing, you can't cover all the use cases, so mostly some things slip through. I saw someone writing a comment about the backdoor that was in Linux recently. The backdoor was quite sophisticated than this CrowdStrike one. I believe the CrowdStrike one didn't have a releasing strategy where they release in batches. That is like a norm in all other institutions. Like many institutions I know, they release their software in batches where they have some feature flags. That's what we call some feature flag sort of thing where they release in batches, realize if it fits exactly into the entire system very well before they release to the entire market or the entire audience. So I think they've learned. I believe they've learned, and then going forward, they would put in place better systems, and then all other software organizations would also review their CI/CD and then find better ways where they can release software, because this was shameful, and then it's a lesson for all of us.
It is, and I expect a lot of people will be asking their vendors and being able to ask them, how do you release updates? I think a lot of folks will be talking, if they have endpoint detection and response systems or any other kind of systems that do these kind of updates, they may be asking those vendors those particular questions and saying, what are you doing? And educating themselves around what are those systems.
There's an important point here, namely that cybersecurity, resiliency engineering, all those type of things, that's a culture. It's not a checklist, it is a culture. It's a culture of constant improvement. It's a culture of being aware of the best current practices in the industry and constantly trying to improve on what you're doing and share the knowledge about what you've learned with others. That is, I think, incredibly important. Security is a culture, and it's not something that you will gain from going through compliance checks and filling out big forms and getting a certification. Organizations that have a large customer base, in addition to all the compliance stuff, they really need to have their culture in place. From what I read at CrowdStrike, they are close to being good with their culture. I don't know the company, but from what I read, they're doing their best, but there are improvements possible. There are also organizations for which security is only a checklist and not a mindset. And those I fear more.
Okay.
I think these are good closing words, by the way.
I was just about to ask that.
Joe actually raised a really good question in the chat, which is that one of the things that just pointed out was that in many environments, there is what he mentions about the idea about a rollback mechanism to roll back a change. And many automated systems have that as part of it. There's even some where the change gets committed, but it will automatically time out. It'll roll back to what was before because of the fact, unless commit that it's okay. There's ways you can do that. The problem that happened in this case, again, comes back to this kernel level thing, where it was at this very core of the operating system that happens, it loads kind of at the boot time of the system, et cetera. There's no way to roll back from a failure of that kind. When you get a blue screen of death on Windows, it's truly dead. You can only reboot the system. There's no way to do it. And in this case, when you rebooted it, that driver would load again, which would have the same failure and would reload again, and you would have this kind of issue. So there is, I mean, rollback mechanisms are part of a good large-scale deployment system, but it comes back to this particular case had this kernel-level driver, which was not something that we could roll back very easily. That's the problem in this particular case, which goes to Olaf's point, that there is work happening to make sure that in operating systems, things can't run down at the kernel level. There's other ways for them to go and interact and get the same kind of, again, remember, CrowdStrike's trying to do this so they get a view of the whole system. They want to get that viewpoint of everything. There are other ways being developed to give security software, et cetera, that kind of view, but they're not there yet in all places. Thank you for that question or comment.
Thank you so much. I think Olaf already said he has given his last words. So is that your last words too?
Well, I would agree that cybersecurity, any of these kind of things, it is a culture, is a mindset, is looking at how to do it. I would again say, as I've said, we live in a complex world. The opportunities of the internet, the things we are able to do, come with the trade-off that things are more complex. That is it. We can do all of this stuff. We can communicate. We can have video calls like this. We can do our online banking. We can buy things. We can do an amazing amount of stuff. But it comes with complexity. And as especially companies using these systems, we need to understand that complexity. We need to figure out what are the trade-offs, what are the systems, how do we protect ourselves? And again, coming back to that magic word of resilience. How do we ensure our systems are resilient in whatever way? Can they function if they're offline? Can they work with this? What happens? Learning all of that. That's the key. The internet is a global network of networks. It's an amazing system that's out there. And we just need to understand how do we make it more resilient for all of us, because we are all interconnected in this extremely complex environment. So thank you all for watching. Thank you to the Online Safety SIG for hosting us and having us come in here. I would also encourage people to check out pulse.internetsite.org to learn more about the systems and the measurements and the pieces we have there. And thank you. Thank you for caring enough to be here to figure out how to make your systems more secure.
You are a true salesman, my friend. Waiting to pause again.
It's what I do.
In the end, this particular case was not an internet issue. The next complex issue in our digital environment might be an internet issue. There certainly will be one.
Great. So
thank you for being with us.
Yeah.
Thank you so much, Olaf and Dan. So our wake-up call. Cybersecurity is not a checklist, but a culture. So we need to keep updated and keep up with what we do daily. All right, so to our participants and co-hosts, Ida, Dan, Olaf, to everyone who joined, and to my leadership team of ISOC-NY TV, thank you so much for making time to be here. And we greatly appreciate the time of Olaf and Dan.